I would like to solve this question. 3 cards are drawn from an ordinary 52 card deck without replacement, which means that drawn cards are not placed back in the deck. We assume that at each step, each one of the remaining cards is equally likely to be picked. What is the probability that none of the cards is a heart? So in 52 card deck, we have 4 categories: diamonds, club, spade, and heart. And in this question, we want to draw 3 cards and we want to find the probability that none of these 3 cards is a heart. So let's define the events first. Let A1 be the event that the first card is not a heart. Then let A2 be the event that the second card is not a heart, and A3 be the event that the third card, the last card, is not a heart. Okay, now that we define the events like that, the question is, what is the probability that none of the cards is a heart? So we wish to find the probability of A1 intersection with A2 intersection with A3. This is the question. This is the one that we want to find. Okay, we can solve this question using a tree. Let me graph the tree. What is this tree? I started the experiment. I started to draw the first card. The first card can be something else, not a heart, or it can be a heart. What is the probability that the first card is not a heart? So for that, I'm gonna graph a table. Now I'm gonna say that the first card, when it is not a heart, how many cards do we have at the beginning? We have 52 cards, and the first one is something else. It can be a club, diamond, or a spade. So since in each of them I have 13 cards in each of these categories, so I have 39 choices for the first one that not be a heart. So I drawn one card with the 39 over 52. And the probability that the first card is a heart, it would be 13 over 52, which would be 1 minus of that. Great. Now, what is the probability? And here, what it's saying is that I draw the first card, okay, and it was not a heart, it was something else. So that I don't have the replacement, I have 51 cards left. Out of these 51 cards, the second one, I don't want it to be the heart. So it would be from the other 3 categories. They had 39 cards in them. I picked one of them, so I left with 38. Great. So, and here I have 38 over 52. I'm sorry, with 51. Good. And how about that my second card is a heart, which is I have 13 choices. In the case that the first one was not a heart. So the first one was not a heart and I have 51 cards left. Okay. Now, how about the third one? So let me graph the second card also in here. So I pick 2 cards. I left with 50 cards now. Okay. And the third one, also, I don't want this to be a heart, which means that it should be from the other 3 categories. Originally, they had 39 cards in them, but I picked 2 of them, so I left with 37. Okay, so this is 37 over 50 cards. And if the first and the second card is not a heart, okay, I'm trying to write this one. So I left with 50 cards and I want the last one to be the heart. It would be 13 again. Okay, so as you see, this is 13 over 52, 13 over 51, and 13 over 50 for this step. Okay, but for the step that the first one is not a heart, the second one is not a heart, and the third one is not a heart, I have this. Okay, this is basically multiplication rule. Let me write the formula. Probability of A1 intersection with A2 intersection with A3. It would be what? I want the third one not to be a heart, the third one not a heart, given the fact that A1 and A2 are not a heart. This one is this step, okay, which is 37 over 50 times. The second one is not a heart given the fact that the first one was not a heart. So probability of A2 given A1. And probability of A2 given A1 is here. It is 83 over 51. And now the probability that the first one is not a heart, it would be the probability of A1, which is 39 over 52.